So we're looking at the concept of costs here in this video. So to start with the basics of it, you'll notice there we have a column of fixed costs. Now, the very definition of costs being fixed means that they don't change. But what fixed costs actually means in this context is that they don't increase in line with production. So things like the mortgage or the salaries of your management team, they won't change whether you produce 1 unit of output, 8 units or 100 units of output. They still have to be paid. So in that sense, fixed costs means that they don't change. So in this case, we have a fixed cost of €25. It could be 25,000. It doesn't matter. So it's 25 all the way down because it doesn't change in line, as we see there, production going from 0 to 8 units. Our variable costs change in line with production. So at 1 unit of production, our variable cost was €20. At 2 units, it was 27 and so forth. And at no units, it was a variable cost of 0, right up to a variable cost here of 145 at 8 units of output. To find total cost, it's simply fixed cost plus variable cost equals total cost. So they're your total costs of production. So even at an output of 0, total cost was €25 because you still had to pay the mortgage, the management team, and any other costs that had to be paid irrespective of the level of production. And then each unit that we produce results in a total cost there going up from 25 up to €170. The next columns then that you could be asked, you may not be asked all of these in an exam question, but this is as much as you can be asked. So we've got average fixed costs here, and this is just the average fixed cost divided by the number of units of output. So for example, the first one there is €25, and that is obviously €25 divided by 1. The second unit of output results in an average fixed cost of €12.50, which is simply 25 divided by 2, and so forth. Our average variable costs are the variable costs here divided by the number of units of output. So just take 60, for example, divided by 5 equals 12. And just fill that in and just take your time going down through that, because nearly every time you're asked to fill out a chart like this, you're asked to draw the resulting curves with it. And if any of these are wrong, the curve will be wrong and then you'll have wasted your time. So just take that bit of time. There's not much to it. And in some questions, you might even see, something like AFC, fixed costs, divided by quantity of output. It might give you that, clue as to how to do it. But anyway, it's fairly obvious if you just think of average fixed cost or average variable cost. Now, I have put both options in here. It's normally just AC, and 95% of the time in economics we just talk about average cost. But it is also called average total cost, which is simply then the total cost, which is here, divided by the number of units of output. So just to take there, for example, a total cost of 70 divided by 4 then results in $17.50 average cost. And then the one that causes some problems here is marginal cost. Okay, so marginal cost is just the addition to total cost as a result of producing 1 extra unit of output. Okay, so the column that we're concerned with then is this one, just highlighted in a different colour, to get our marginal cost. It's the total cost, okay? The total cost for 1 unit minus the total cost for 0 units. So just as a rough idea, it would be TC, let's say 4 minus total cost 3. Okay, or even starting off total cost 2 minus total cost 1. So in other words, it's the new total cost. We'll just take this one down at the bottom. So the total cost for producing 8 units was €170, and the total cost for 7 units was 130. So that would be TC8 minus TC7, and that's 170 minus 130 equals 40. And there's our marginal cost of 40. Now, in some exam questions, they leave this one blank. If they leave it blank, my suggestion is to fill it in. But sometimes they actually darken it out, in which case then you would just abide by that and not bother filling it in. But for me, there is still a marginal cost here at 0, because before there was anything, you didn't have any cost, and now you've, management cost and a mortgage to pay. So I just fill it in. It makes the graph look better in any case. But you may not have that option, because sometimes they actually blank it out. So that takes care of that. So each of these then, for example, marginal cost for 2 is just total cost for 2 minus total cost for 1. And then that's 52, there you can just about see it, minus 45 is 7. And then that's 60 minus 52, and that's 70 minus 60, and so forth like that. So they're your marginal costs. And what that means is, marginal again, is the extra cost as a result of doing one extra thing, of producing one extra thing. So what is the addition to total cost as a result of producing one extra unit of output? Now, to play this out, when you're asked to plot your graphs, this is what it will look like. So the most that you can be asked to draw is the 4 graphs that I've shown here: average variable, average fixed, average ATC or average cost, and marginal cost. So simply then, no more than with any of the work you've done up to now, the price goes on the y-axis. This time it's the cost, and the quantity still goes on the x-axis. So just mark out then the various intervals that you will need up along the y-axis, and then the number of units of output. So we know it only went up to 8, so we only went up to 8 here. Just as a guide, sometimes people struggle with, well, how many intervals will I have going up the y-axis? If you just look at the curves that you're asked, so it's just this section here. These are average variable cost, or average fixed cost, average variable cost, average total cost, and marginal cost. They are the only 4 curves I have to draw. Just look at this. The smallest number will always be 0, obviously. So then just what's the biggest number that you can see here? So there's a 40 there. Is there anything higher than that? And you would always then allow a little bit either side of that. You can see 45 there. So you just go up to 50. And then that means then just, a centimetre per interval. So go up in 5s, and then you'll easily fit it into an ordinary A4 sheet. So the important thing about this is that, even though you think, well, that's pretty obvious, is that your scale looks good. Because the last thing you want is a diagram where everything is squashed in so flat that you can't actually see what's happening. And that will happen then if your intervals aren't as they should be. So back over to the graph. So just plot your 4 curves in that you were asked for. Average variable, and just to, I've colour coordinated it there, so you can see the green one there is the AVC. The blue one is marginal cost. The black one is the average fixed cost. So just to go down through the logic then of each of these, what's happening here. With average fixed cost, there's the first one. Okay. That continues to fall with output, because fixed cost doesn't change. So with every unit of output that you add to total production, you're spreading your fixed costs across a broader base. So to go back here, the fixed cost, whether I produce nothing at all or 8 units, is still €25. So my average fixed cost will continue to decline and continue to decline. Average variable costs, you can see they actually, it's U-shaped there, so starting off up here at 20 and going down then as low as 11.25 and back up then to 18.13. So that's then reflected in that U-shape, that green. And if you can see the shape of it there, but it is somewhat U-shaped. Your average cost curve will be U-shaped, that's the red one. And then the marginal cost curve is also U-shaped. Okay, some books will show that it's going upwards from left to right, and that's not actually true. And this is where, if you remember when I mentioned putting in that first marginal cost, is important to construct that graph, because the shape of the U-shaped average cost curve, the shape of the average cost curve is determined by the shape of the marginal cost curve. So just to take out a couple of these, average fixed and average variable. We can just take those out of this. And we'll leave it here at just these two curves. And I'm just going to get rid of some of the ink here, because 90+% of the time, this is all you're asked for, is the average cost curve and then the marginal cost curve. So the red and the blue. Now, there's a couple of points here that are very important to interpreting what's happening here and what's going on in this curve. The U-shaped average cost curve is the red one, first of all. So what causes average cost to go down is the fact that specialization can take place. So in other words, the cost per unit will decrease. You will end up paying less per unit of production because your workers get more efficient. And the other reason is that fixed costs are spread over a greater number of units. So you remember that 25 divided by 1 is obviously 25, and 25 divided by 2 is 1250. So, and it continues to decrease in that way. But then it comes back up again. Okay, you'll notice that. So that means that diminishing marginal returns are kicking in. You are becoming less efficient at producing this item, whatever it might be. So that brings your average costs back up again. And that's inevitable if you think of any scale of production at all. Take our classroom, and then we're all in the room and we're working away, and you add another person into the classroom. It doesn't make any difference, might even make us a bit more efficient. But you can imagine if you keep adding people in, we sooner or later run out of desks, of chairs, of my time, and then somebody's sitting for half an hour waiting on me to get around to them and help out. And they've wasted their time. But I still have to pay that worker, even though he didn't actually get anything done, because for various reasons we couldn't get access to the tools. There are too many of us, whatever it might be. So that explains the shape, the U-shaped nature of the average cost curve. But the marginal cost curve reflects that. So even though some of the textbooks will show a marginal cost curve starting about there and going up, it actually must be U-shaped because it mirrors the average cost curve. So marginal cost goes down and then back up, and so does average cost. And the simplest way to think about that is if you consider your exam results going across a term. If your average result, you've done 3 exams, if your average continues to fall, that means that the additional result that you got, your marginal result, has also been low. It has been lower than your average. If, and here we're crossing the crucial point here, if at this point your additional result, in other words, your average was 50 and you now got 60 in this exam, that's going to bring your average back up again. So it's the same with costs. You initially start off that your marginal costs go down and then they start to go back up. And then the average will follow that, but later. There's a lag between the average and the marginal. So bearing in mind that we said that once costs start to go back up, you've hit diminishing marginal returns. But that will only start bringing the average up subsequently, not right away. The next thing to be wary of is, and just to highlight it again in particular, is this point, that the marginal cost curve can only ever cross the average cost curve at the lowest point. You will regularly see, sometimes even in exam papers, and certainly in the textbook, a marginal cost curve. Let's say there's your average cost curve, and it's just flung through like that, right? That can't be. And the reason for that is that if the marginal result, the marginal cost, is going up, that has to bring the average up with it. It can't do anything else. There is no way that your average in a test or in a series of tests could be 50%, and then you get 75%. And then that bring your average down. So just focus on that. The marginal cost curve must cut the average cost curve at the lowest point.